Alright, this is lesson 1-6 in Algebra 2, Unit 1, Lesson 6, Solving Absolute Value Equations and Inequalities Algebraically. First, let's think about and talk about what absolute value is. Absolute value is a distance, and it's specifically the distance from 0. Okay? So since it's a distance, it's always a positive number. Okay, so absolute value is always positive. So looking at, and what I mean by that is if you see these absolute value marks, this number here will always be positive. So in other words, if you have the absolute value of x equals -4, that's not possible. And so you would tell me when you see that kind of equation, if that's your original problem, that there's no solution because the absolute value of anything can't be a negative number. So let's erase that and go on and work this problem. Now, being absolute value, there's two absolute values of x that will equal 4. And in this case, well, I guess I could just work on this number line that's already here. Okay, looking at this, 4 units away from 0, there's a positive 4, but 4 units away from 0, there's also a -4. So the answer to this, absolute value of x equals 4, will be that x equals 4 and x equals -4. Now notice in these two answers there's no absolute value marks. That's the answers to this absolute value equation. And you would draw, in this case, the answer would be a point at 4 and a point at -4. So when you see this equals, we're going to get into inequalities in the next page, but if you have the equals, your answer is 2 points. They're not always equal distance from 0 because sometimes you've got an equation equals a number. Now, I'm not going to probably use this preliminary line. I'm going to just put the answer on the line. The way you set up absolute value equations, because there's a positive choice and a negative choice, you set up one, just take away the absolute value marks and write the equation just like it is without the absolute value marks. And the other equation, the second equation, you take away the absolute value marks and it equals your negative answer. So 10 and -10, both of them have the 3x plus 4. Then you solve it. Subtract 4 from both sides here and here. So you end up with 3x equals 6. So x equals 2. And you end up with 3x equals -14. So x equals -14 thirds. And those are your 2 points that you're going to put on the number line. So you place your 0, and at 2 you have a point, that's a solution to that equation, and at -14 thirds you have a point that is a solution to that equation. Okay, now again, same thing, set up two equations. One, 13 minus 5x equals 2. And the other one will be 13 minus 5x equals -2. Solve them. So you subtract 13. That gives you -5x is equal to -11. When you divide by -5, x is equal to +11/5. And on this one, you subtract 13. You have -5x is equal to negative 15, dividing by negative 5 then, x equals 3. So your 2 points are 3 and 11/5. So at 3, we put a point, and at 11/5, you put another point. All right, that's how you do the equalities, the absolute value equalities. Now let's look at some inequalities. When you look at the inequalities, this is where, remember from lesson 1-3, I talked about if you have a conjunction, okay, you have a conjunction that is less than, now I can't get my stylus to write, let's try it again. Okay, if I have a conjunction, I'm going to have the sign less than or equal to, and it's going to graph between 2 points. If I have a disjunction, the symbol will be greater than or equal to, and when it graphs, you'll have your 2 points, and they could be open circles too, and then your shaded in area will be away, arrows that are pointing away from each other. So looking at our first one, you can see that the symbol here is a less than, so this one is a conjunction. So we write our 2 equations. 3x minus 4 is less than or equal to 8. And we can solve that. Add 4 across. 3x is less than or equal to 12. And then dividing by 3, x is less than or equal to 4. Now the trick on these inequalities is for your negative choice, you're going to have to reverse the sign because that's basically you've multiplied through by a negative. So for your negative choice, you have to remember, reverse the sign. Okay? So when I make my negative choice here, let's move this over and go look at it again. We have 3x minus 4, and we'll have a negative 8. That's what I mean by the negative choice. So instead of less than or equal to, it needs to be greater than or equal to. And then you solve it. But that's something you have to remember to do. Add 4 to both sides. So you have 3x is greater than or equal to negative 4. Dividing by 3x is greater than or equal to negative 4/3. So you have negative 4/3. And up here at the other end you have a 4. Now let's look at our inequality. Remember, for a conjunction, the answer is always one equation. So I have to put these 2 back into one equation. I have negative 4/3. And I have x. And I have 4. And remember, with a conjunction, your signs are going to be less than. But verify. If you look at this negative equation right here, the less than points to the negative 4. So this is going to be less than or equal to. And in this other equation, the sign points to the x, so that's also going to be less than or equal to. Since it's less than or equal to, you have shaded circles, and you're going to color or shade the line between the 2 circles. All right, looking at number 5, we believe because the sign is greater than, this should graph as a disjunction. The arrows will be pointing away from each other. Let's set up our two choices for the equations. 6 minus 2x is greater than 14. And then the other choice will be 6 minus 2x is less than negative 14. We're going to subtract 6 from both sides, which will leave us with negative 2x is greater than 8. When I divide by a negative 2, though, because that's a negative, I have to flip the sign, so I have x is less than negative 4. So graphing that, we have negative 4 here. Less than will be an open circle, and since it's less than, we're going to shade left. All right, for our other equation, subtracting 6, so negative 14 minus 6, we'd have negative 2x is less than negative 20. When I divide by negative 2, x is greater than 10. We have to turn the sign around. So we have a mark here at 10, open circle, and it's going to shade greater than. So this does graph as a disjunction. The arrows point away from each other. Now on the equation, on your answer, you need to have two equations for a disjunction. And you need to have the word or between them. So this final answer will be written x is less than negative 4 or x is greater than 10. Our last example is another conjunction because the symbol is less than. So this is another conjunction. So it'll be 2 points with a line between them. We have 3 minus x is less than 2. And 3 minus x, again, remember for the negative choice, you flip the sign so it's greater than negative 2. Subtracting 3, you have negative x is less than negative 1 because you subtract 3 across here. Multiplying by negative 1, x is greater than 1. Now when I subtract 3 over here, we have negative x is greater than negative 5, but I multiply through by negative 1 again, so x, flip the sign, is less than 5. Again, a conjunction, the answer is written as one equation, always in number line order, so 1 is lower than 5. The arrow here points to the 1 as it should. We would expect they would both be less than, again, because it's a conjunction. And this points to the x. So this is my final equation answer. Again, conjunctions are one equation. A compound inequality is what they will be. One compound inequality. And we're going to mark our 0, our 1, and our 5. They will be open circles because it's less than, not less than or equal to, and shade between the two. Because x is between, any number between 1 and 5 will give us an answer for x. That's a solution set. When you have an inequality, your answer is not one number, it's a lot of numbers. It's a set of numbers.